Welcome to another exciting episode of From the Source with your hosts, me, Ilkka Turunen.
Hi, and I'm Brian Fox.
And Brian's had a haircut.
I did, but I have your favorite all-day DevOps hat here somewhere, just in case I need it.
I still haven't received mine. But I'm glad that we've kind of moved past the hat-wearing stage, and we've got to the fresh buzz over here. Well, hey, Brian, we've got a pretty interesting episode today. I feel like we're kind of in our comfort zone today because today's topic is to do a deep dive on the latest State of the Software Supply Chain report. So I think a lot of people might not know what that is. So why don't you tell us sort of what the report is and kind of what sort of info we usually publish in it?
Yeah, sure. So this is our 10th year of doing what we call the Sonatype State of the Software Supply Chain report. And Sonatype, we run the Maven Central Repository, which is the repository where all the world's open source Java components are sourced. And that provides really unique visibility into what's going on inside of the ecosystem. Which versions are popular, which ones aren't, which ones are being updated, which ones aren't. Geographic trends, time trends, all kinds of stuff. We can do really deep research on there. And we pair that up also with our Nexus open source telemetry. We have like 150,000 instances of Nexus open source out in the world. Those instances are proxying NPM for JavaScript, PyPI for Python, Ruby gems, NuGet for .NET, Docker Hub and crates and Conan, and the list goes on. And so that provides us a pretty wide visibility into what's going on inside of the other ecosystems besides Java. And we use this data. We often also do surveys. Sometimes we do partnerships. This time we did a couple partnerships with different orgs to pull in different pieces of data and try to look at what's going on in the industry. And each year we tend to take a different look at what's going on. So it's not like the same report just updated every year. We do new and novel types of research every single time to try to understand things like, why aren't people fixing dependency vulnerabilities, or, what's going on with malware, efficient algorithms for detecting whether a project has high quality or not, looking at their behavior. So there's a lot of different things over the last decade that we've looked at, but that's generally what the report is all about.
Yeah, and it's really interesting because over the sort of last 10 years, we've been looking at so many different facets that it feels to me like I'm still talking about a couple of research points from like a report 3 years ago, because it's still very relevant to what people are doing right now. And sort of the lessons sometimes get a little forgotten, and sometimes it's actually interesting also to take a couple of years of gap and take a look at if things have changed. Like in this year's report, there's a couple of items that we sort of refreshed, and having a sort of corpus of that long data, it really kind of gives you a perspective of how things have changed or not changed at all. So it's a very interesting read, and actually, kind of a lot of sort of nuggets of information when you take them individually, kind of make you go, oh yeah, okay, that makes sense. Like, for example, if we start from the very, very top, sort of the first big thing that we reveal in the report is open source adoption kind of sits at sort of a multi-trillion request scale now. I think we estimate about 6.6 trillion total downloads, and the bulk of that is formed of JavaScript and Java, the ecosystem. So I think together those already get to about the 6 trillion request count. But aside from that, kind of the biggest ecosystem that's growing, surprise, surprise, is Python. And can you guess?
How do you think that is? Anything interesting happen in Python land this year?
Yeah, let's think back. Chat LLMs, generative anything.
This AI thing.
Yeah, this whole AI boom. I'm sure it's old hat now, old news, but an incredible amount of sort of software supply chain infrastructure has been formed around not just the LLMs themselves, but also all the tokenizers, all the inference work that goes into training models. Is basically distributed as Python packages, is distributed through these software ecosystems. So actually Python's just done a double whammy of it's the most popular programming language now on the planet, at least according to TOB and GitHub, and now it's also boosted by AI, so it's really rocketing quite heavily.
Yeah, it is. It's not unexpected, but it is interesting to see the massive growth there. I mean, JavaScript has always been the one with the most modules, most consumption, just merely because the individual pieces are so much smaller. In a Java world, it's like, imagine if each class was its own module, you'd have 10, 100x. That's kind of what happens in JavaScript. But to see Python kind of trending along similar numbers is a huge step forward for sure.
It just shows you that the march of open source has not stopped. I mean, the growth rate's 40% year over year or something like that, right?
Yeah. Every year, it looks the same every year, like it hasn't changed. Yeah.
Well, in fact, this year's number, if you look at the diagram, it's actually show up even sort of sharper than it's been before. So yeah, if anything, it's speeding up.
Yeah. Yeah. The usage is like a fractal. The more we look at it, the more we zoom out, the shape, the growth curve looks the same. Yeah.
Yeah. But obviously, sort of the next item in there is that there's also the sort of the underside of this. And this actually came out. I had a couple of chats on Blue Sky, which is where tech Twitter has now migrated to, apparently flown up. And there was an article actually written about this report, and it kind of really honed in on the risk side. And I think it's important that we understand the risk side as well. And that's something I really enjoyed in this year's report. It was to sort of seeing the evolution of how these things started from sort of named exploits in the early 2010s and all of that to sort of the situation that we're in right now.
Yeah. So one of the things that I wanted to do this year, given it was the 10-year anniversary, is really, do a look back over the different things that we've investigated over the years, refresh things that we haven't looked at in a while, and also just kind of take in how the industry has changed in those 10 years. And, 10 years doesn't seem like a lot. We founded Sonatype 17 years ago. So 10 years is, a little bit more than half. But we were well down the path of doing, what the world would now refer to as software composition analysis in 2014. We were several years into it at that point. But it was still interesting to look back and see how early and how much things have changed on the attacker side, right? And so, like, what I did when I looked at the 10 years, I kind of sat down and said, okay, we've got the attackers, we've got the open source publishers, we've got the consumers of open source, and then we've got the regulators. And what has everybody done in those 10 years? And unfortunately, the attackers have made the most progress, right? So 10 years ago was one of the first big struts vulnerabilities, not the Equifax one. That wouldn't come for another 3 years at that point. But it was a smaller one that didn't get as much notoriety outside of at least the financial sector. And the financial sector was using struts a lot back then. And so there was this vulnerability, and it was properly zero-day processed. It was disclosed, responsibly fixed, announced. And then it was days to weeks after that announcement was when the attackers jumped on it, right? And I know this firsthand from some of the mailing lists that I have access to, that I could see, in fact, that was happening. This wasn't a case that it was really being massively exploited before the disclosure, it came after. And so, one of the big dramatic shifts, old presentations I had at the time was highlighting the difference between, a fairly recent IBM report at that time that was showing that attacks came, weeks to months following these disclosures. But in this case, it was a dramatic escalation to days. And Anonymous was making a name for themselves around this time. And so big banks, kind of everybody suddenly had maintenance all at the same time, right? So read between the lines, if you will, but nobody raised their hand, nobody got hauled before Congress, nobody really got fired over this, but it was one of the early shots across the bow. That same sort of cluster of years, we also saw Shell Shock and Heartbleed, right? These were two very widespread open source security issues. Not so much open source components in the way that we tend to focus on them at Sonatype, like struts, like Log4j, but definitely open source in general. And because of the widespread nature of those, they did get some attention. They had logos, they had names, they were celebrity vulnerabilities, like we refer to them these days. But then not a lot changed. It kind of went back. We regressed to the mean. Fast forward a few years, the Equifax breach happened. That was announced to be, caused by a different struts vulnerability. The difference there was they were pretty open about it, but then there were congressional hearings, and C-suite lost their jobs over some of these things, and it was another awakening of people starting to pay attention to what's going on. Around that same time, however, I saw and started writing about this rise of intentionally malicious components, and components whose attacks were designed not to go after the end user of the software, but actually trying to steal things from open source publishers. Credentials to publish into these public repositories were in fact the target. And I remember thinking, why is nobody talking about this? This is a dramatic shift in the attack mechanism. And, we've been talking about that for now 7 years. And I think it's still something people struggle with. They don't recognize this threat.
There was literally one this week where a video player component had their, I think it's called Llama Player, got their author credentials stolen, and somebody literally went on NPM and published a couple of malicious versions. And what it did was, if you had it embedded on your website, because a lot of people have it on CDNs, it actually just displayed hey, connect your crypto wallet to this website type of situation, like log in with your crypto wallet. And if you'd done that, it would have just stolen your crypto. So yeah, unfortunately, people struggle with it.
So silly, that's exactly what I expect. If I'm watching an embedded video, of course it makes sense for me to enter my crypto credentials. But the point is, they do these things because they work.
Yeah.
Yeah.
I mean, point, isn't it? Is like that what often gets lost in this discussion is that even if we've said it, even if it's been said 5 years ago and it feels like a very blasé risk, it's still a risk.
Still
in fact, if anything, those things are happening like more.
That's right. So that is continuing to explode. We're going to get to that exact number in a second, but continuing the evolution of these attacks, what finally I think got regulators and the industry in general sitting up was sort of two rapid fire things in back-to-back years. The first was SolarWinds, which was not really a component-based attack, but it definitely had elements, I think it's fair to call it a supply chain attack, right? Where malicious code was embedded into the SolarWinds product that then got distributed downstream. That was a bit traditional. The end user was the target in that instance. But certainly government was heavily affected by this as users, and that really started getting people to pay attention. And then before, the news cycle moved on and everybody went back to the mean, then we had Log4Shell, right? And that I think finally got regulators and everybody sitting up and kind of looking at this challenge. As we'll talk about, it wasn't awesome in all of the instances, but it definitely finally, I think, broke through. And if you're thinking about that timeline, that's like 7 years from some of these early ones till it became really, really prevalent. And then the other kind of bellwether thing that happened this year was this attempted attack on XZUtils, which is a compression library used in Linux distributions. This was, a several year long attack to get access to a single maintainer project. They created meaningful code. They created very sophisticated backdoor tech. If you haven't looked into it and you like code, you should definitely look into it. The way they hid that in plain sight is in some levels fascinating, right?
I mean, it's genius if it wasn't evil.
That's right. It was very fascinating to see that, and it was a near miss. And so I predict that this one will be like that first struts thing. It's the thing that happened, and most people forget it happened some number of years from now, when finally these things happen enough times that it becomes the norm. Because I think XZUtil scared a lot of people, but I feel like the conversation has moved on back to the basics, and this problem didn't go away. There's 0% chance that the attackers, having gained access to a project 2 years ago, just stopped at one. Because they had 2 years to gain access to others before they attempted the attack. So it just logically makes zero sense that would be the case. So we have to assume that there are more out there, and we just don't know about it yet.
Yeah, I think it was the OpenJS Foundation put out a press release a couple of months after, where they actually said that they found some traces of evidence of sort of similar psyops, where the maintainers started getting these sort of very.
I've seen the emails. I helped connect the dots on that one. It was basically the same. They made more mistakes, so it feels like they farmed it out to junior engineers to try to replicate. But that also happened. That happened within the last year. It was very recent at the time we discovered it. So there was still a 2-year gap between that first of takeover and this other failed attempted takeover. What's happened in between by the ones that got it right the first time? That part, I think that story is still being written.
Often when we tell the stories like this, people kind of get stuck on the fact though, hey, that's one example. But where there's smoke, there's usually some fire, and one of those sort of key things that we see is we kind of keep track of when we see a malware incident, like something that is malicious in nature, either these takeovers or somebody outright publishing malware or things that we consider malicious. And we kind of publish a number on that every year. And this year it actually hit topped just over 700,000. And I think you were saying to me yesterday that it's probably closer to 800,000 by this stage.
Yeah, by now this stat, because we were writing the report over the summer, the stat's a few months old already. So we're probably closer to 800. Yeah, but it was 250,000-ish at this time in last year's report. So now we're at 700,000, and this continues to explode. We were seeing 600, 700% growth in early years on small numbers, but the fact that it doubled last year and it doubled again this year on much bigger numbers is significant. And I'll take the moment to point out right now, we did some other research in a different part of the report this year. There's about 7 million components out there in the popular open source ecosystems. Some of the research we did was to find out which ones are actively being downloaded, which ones are actively being used in applications. It's about 10% of that. 10% of that is 700,000. That's about the same number of these intentionally malicious components that we've tracked over the last handful of years. That's pretty striking when you think about it. When you think that as we sit here right now, we're probably already in a place where there have been more fake malicious components published to NPM and Python and some of those ecosystems than exist in popular components in all of the ecosystems combined. So from a developer perspective, the signal to noise ratio is going in the wrong direction.
That is a pretty profound and pretty alarming thing when you think about it. I mean, the counter argument to that has always been, well, we know which projects are good and we will stick to that. But increasingly, when we looked at the makeup of the types of malware that we actually saw, I mean, a couple of things that really stood out to me was about half of it is sort of what we would class as, well, not quite half, 40% is what we would class as sort of potentially unwanted features, and which is just packages doing stuff that they don't tell you that they do, which can range from just protestware, things like, hey, I don't want to do this for free, anti-work protest type stuff, to more malicious stuff like a little bit more advanced protests that actually delete your files if you've got certain keywords on your system, to where we start getting to much more serious type of malware being distributed, being pushed out. We've even seen cases, this exit key case was like the most genius because it was very bespoke. It was hidden over 2 years. It was encrypted. It was hidden in the file encryption sample files, which is just, clever, evil, but clever. But you do see a fair amount of malware that, for example, steals environmental secrets, steals authentication tokens, steals developer environments. And the more that we've looked at it, it actually fits really well into the sort of standard criminal ecosystem. So the National Cybersecurity Center here in the UK published a killer of an article a couple of years ago where they spoke about how the ransomware ecosystem works, where we've got these, gangs that gain initial access, and they do it by distributing malware. Then they kind of bundle that access, like, hey, here's 100 machines from Bank X onto these affiliate marketplaces, and then they get picked up by actual ransomware gangs or criminal gangs that then do the thing, which might be dropping ransomware, stealing secrets, executing other sort of subsequent attacks over there. And what's sort of been chilling is the types of malware that we discover, especially the really, really serious stuff, is stuff directly connected to that criminal ecosystem. So it's clear that it's not just individual operators kind of doing proof of concept packages. It's fairly organized stuff,
right?
You see there. The sort of inflation of that just shows that that the growth of that number is growing way faster than the growth of open source consumption itself, which kind of tells you that the bad guys are really adopting it at scale. Which isn't to say
it's working, and it's working because we don't have good defenses around it, right? So the way you manage your typical vulnerabilities is very different here. Right, a vulnerability is a bug that may or may not be exploited. Oh, these malicious targets, they execute as soon as a developer downloads it, because these ecosystems execute things. So that's part of the challenge. You need to defend against it up front. We've been building solutions for this for a long time because, frankly, back in 2017, I started talking about this, and I had some, customers, audience members come up and say, Brian, how do you help with this? And I didn't have a great answer, honestly, because it was a very different dimension to the problem. So we sought out to build a solution for this. And this is how we've been catching all of these malicious components for all these number of years. So definitely there is a way to solve this problem. But I think many people want to think about it like vulnerabilities. And, I did some stuff on LinkedIn earlier this year trying to play with some analogies. And, I think the one that sticks is more of a food-based thing. Like food might go bad, might spoil, right? And that could be considered a vulnerability. A piece of moldy cheese, for example, you might cut the mold out and eat around it. Like that's a thing, right? Or bread.
You look that goes bad and curdles.
That's right. Yeah. But in this instance, you might look at it and you cut out the bad piece, but you wouldn't do that if the food was poisoned, right? It's a very different thing. You don't look at, if I told you one of your devices had an explosive in it, you wouldn't say, it's okay, I'm going to update my software next week. Throw it out the window, get away from it. And so, the malicious element of this, I think, gets caught up in organizations that are struggling to deal with the massive amount of vulnerabilities that are out there. And it's unfortunate because it is a very important thing. It needs to be dealt with separately. And as we're seeing with the rise here, not enough people are. So let's hop ahead a little bit. We're running out of time a little bit, but we also looked at publishers. The open source publishers and what happened in the last 10 years. And just quickly, I'll say, unsurprisingly, we've seen that, 1,400% of them are releasing much more faster year over year. That's not surprising. But what is surprising is the time it takes them to remediate their own dependency vulnerabilities has gone from days and weeks to, on average, 300 days. Right. And part of this is caused by this massive rise of vulnerabilities that are out there. The number of CVEs is skyrocketing, just like the malicious components. And certainly open source maintainers are struggling to keep up, right? So they've reported in surveys that they're spending 3 times more time dealing with these reports, dealing with vulnerabilities, and yet they're still taking on average 300 days to get to them in most of these cases. The good news is we found when we broke it down by organizations or projects that have foundation support, or foundations that have that are being the maintainers are being paid, they have significantly better outcomes. 3 times better outcomes in some dimensions, 7 times better outcomes in other dimensions. So there is a glimmer of hope that if we're able to help better support the open source maintainers, they demonstrably do a better job at producing safer components that everybody is relying on, right? So we need to be able to focus on that a little bit going forward, I think.
Yeah, I think so too. And I mean, one of the findings that we had, I think, a year ago or 2 years ago, is generally open source projects are better than industry at taking these fixes and actually applying them. Often the conversation is about the maintainer struggling. That's absolutely a true conversation. But even cases like Log4Shell, they made the fix in like 10 days. Which is
less than that on a holiday weekend, no less. Thanksgiving, yeah.
Exactly. So if you compare that to what would happen in an enterprise or in a closed source setting, it probably would be a very different story. Yeah. So part of often when I look at these sort of numbers, it's really a symptom of the success of open source itself. Like there's just so much of it, and it's so networked with one another that creates that complexity, and the projects are just like inundated basically with this stuff as a result.
Yeah, I mean, sometimes people look at the conversation. I think this is the article you were referring to before, looking at, highlighting of risk in open source and saying, yeah, but making the false straw man argument that we're trying to say it's worse than commercial. I don't think it is in most cases, but it's certainly easier to observe. And I think the problem lies in the fact that organizations often are making these choices around open source. Well, frankly, the organization is not making the choice. A developer or group of developers are making these choices. They can often be uninformed, and the organizations don't have your typical procurement processes in place to be able to vet and recognize and track and update open source components like they do with the software that they purchase, right? So while probably open source on average actually does a better job at this, because of the way it's procured sort of at the bottom level in development, and without the transparency, the way the organization manages it leads to potentially worse outcomes than what you see inside of commercial software. And I think that's the nuance. It's a little bit hard sometimes for people that want to build those straw man arguments to really see through the noise there.
Yeah, I think so too. And I mean, it's often well-intentioned too, but the problem is because there's just so much of it and there's so little visibility and sort of shared and standards, if you will, that doesn't happen. And that's part of the reason, actually. One chapter, we don't have time to like super deep dive into it, but the last sort of piece that we did in there was take a look at sort of the regulations that are rising as a result. So all of this is for better or for worse. No sort of judgment on the validity of necessity of these.
Yeah, I do want to hit on the consumer one. The last 3 years we've calculated this number, and so we looked at when something is being downloaded from a public repository and it already has a known vulnerability. Is that happening because open source hasn't fixed it yet, or is it happening because the open source consumer hasn't made a better choice? 96% of the time, it's the latter. Only 4% of the time is something consumed with a known vulnerability that isn't already fixed. And unfortunately, in the last 3 years, that statistic has not changed. It's 96% of the time for the last 3 years, right?
Yeah.
And the other one that we've reported on a lot is, the percentage of vulnerable log4j downloads at any given rate. Last year we were at about 30%. We're finally to 13% this year. But look, it took 3 years for the most notorious, most widely documented, discussed, the issue that was on the top 10 list for the NSA's nation state attack exploits for 3 years. And it took us 3 years to get to the point where 77% of the choices are the right ones now. That's still pretty terrible, right? And this is I think, where we see this year after year, is that all these things are happening. The discussion tends to go towards, we need to help open source. Maybe we shouldn't use so much open source. And like I said, we should help open source. The numbers get better when you do. But 96% of the time, the problem is the organization consuming the open source hasn't updated their software. So we can do all these other things, and we should do them. But until the consumers fix their behaviors, we're playing in the margins of that 4% of the behavior, right? And that's the problem that I keep trying to shine a light on. And I think, frankly, this is why the regulators have stepped in, because the things, I think it's a lack of motivation. It's not an understanding in most of these cases, right? And so we did an episode, I think it was last time already, where we went deep on the regulation. So if you haven't seen that, you should go back and take a look at that. But I think, there's a little bit of good news that we're finally getting some regulation after, 15 years of shouting from the mountaintop and not seeing things change. I think some of these incoming regulations, the European Union's Cyber Resiliency Act, the Product Liability Directive in Europe, I think will be game changers. The PCI 4 standards that are coming out, that they've come out, but they will take effect, I believe, in March of 25. Those have elements in it that are similar. They require software bills of materials, things like that. I think those things will finally start to move the industry in the right direction. It's very slow right now, but I think at least we've turned the corner and the right attention is being paid on these things.
Yeah, and that's the path that I think is a good place for us to wrap up today's episode as well. I think the SBOM adoption itself, I mean, in itself, it's a little bit of a controversial subject depending a little bit where you're looking at it. But whether or not we like it or not, it's just become a requirement for all the reasons above. And so it'll be interesting. We do take a little bit of track on how projects are starting to publish SBOMs and what sort of level they're at. So definitely worth the read if you want to kind of look at the data there. But hey, Brian, I think
we're going to get the report. Sonatype.com/SSCR.
Sonatype.com/SSCR. There's a very handy dandy QR code we can attach to this as well. So with that, thanks very much. I'll talk to you next time.